Alright, I have not been very good about uploading videos lately, and there's a lot of excuses for that. I've had a lot of things fail and not be worth uploading. I've been having some motivation issues. I've been running out of material, but mainly it's just down to motivation. I have not been keeping up with the pace here. But, well, I'll just keep on keeping on, or at least when I can. So, I have been very gradually working on a fairly complete explanation of how a stable multivibrator works with just 2 transistors. You can also do them with 555s, and I'll be demonstrating that as well later down. But I wanted to start with the basics, and this thing right here is an astable multivibrator. Let's just give it some power here so you can see what's happening. I actually have it set right now to limp because I've been doing I've been just testing different values of resistors, different versions of capacitors, while sort of confirming and teaching myself exactly how these work, because I know the basic concept of why they work, but I want to actually, teach you guys why they do what they do, and how the feedback between the transistors causes the flow of current to switch between the 2 sides of the circuit. It's actually a really cool circuit that you can make with about 50 cents worth of parts. Anyway, but before I get into this thing, I wanted to talk a little bit about how the capacitors are acting in this circuit. So I'm just going to switch back over to here, where I have a very simple circuit. Where is my whiteboard? Because I guess I'll just sketch this out real quick. What did I do with that? I haven't... Oh, there it is. Pardon me a second while I... Oh, that was a really nasty noise. I bet that was not happy to listen to on the microphone. Alright, so I'm just going to clear some space here for the whiteboard, and I'm going to show you what I have set up here. And then we're going to play with it for a bit while I show you why it works the way it works. So, let's just get the whiteboard in here. Bringing out the whiteboard also reminds me to talk about the Back to Basics series, which I haven't uploaded anything on for a while. It's mainly due to a lack of inspiration. I'm not too sure where to go next with the Back to Basics videos, but I'm formulating some ideas and getting some stuff, and I have a lot of pet projects on the back burner that I need to get back to that I've just kind of forgotten about. But this is not a vlog, this is actually a teaching video, so I need to actually start talking about what I'm here to talk about. So, I have the circuit, and we're going to do plus, and we're going to have that coming in through a resistor, and that resistor is a red, orange, so 22K. 22 for red, and then orange 3 zeros, 22,000. So that's coming in. And then from there, we have an electrolytic capacitor, like this, nice big honkin' capacitor. And then that goes to ground, like this. And then over here, we have a resistor, also 22K at the moment, but I was going to mess around with other values. And it is in series with an LED. So, what is happening with this circuit? Oh, and I also forgot that, although I think I have it on the positive rail, but it doesn't really matter, there is also a switch. So what happens when you click the switch on this circuit? Well, what happens is you go click, and this capacitor here actually, at first, shows as a dead short across the positive and negative rail. So it starts sinking all of the voltage it possibly can, and I will also demonstrate that in a few moments. And so this plate of the capacitor starts rising towards the rail voltage, which in this case is 5 volts. And it's going to go up, and as its voltage approaches the rail voltage, its resistance starts going up very sharply. It's actually an exponential increase, so the graph would look like that, on an axis of time versus resistance. It would look like that. And then, of course, more current starts going through the LED, and it gets to have more voltage. So when you click this button, this LED will slowly start to get brighter and brighter as the voltage across it increases, as the capacitor starts sinking less of the voltage. Now eventually this capacitor will be fully charged, at which point it actually appears as an open. No more current will flow through that capacitor. You can kind of think of it as, what would be a good way to describe how it works? Consider, have you ever taken, I wish I had one to demonstrate it, have you ever taken a syringe and put your finger over the end of it and then pulled on the plunger, and you pull a vacuum on the inside of the syringe? That's kind of what's happening here. We've got a positive potential building up on this side and a negative potential building up on this side. So there's like an electrical pressure building up inside of that capacitor as voltage is being supplied to that circuit. And eventually it reaches a point where it can't pressurize any further, so that is the point at which it appears as an open in the circuit, and no more current will flow through it. So then that LED will, then be at full brightness, and I'll demonstrate that just a moment. Then when you open this switch, the pressure in that capacitor has to go somewhere. Now, if this part of the circuit weren't actually there, that capacitor would just sit there charged, and the pressure wouldn't have anywhere to go. Granted, there's some internal resistance, so the pressure would droop off after a while. But if it has nowhere to go, it's just going to sit there. Now, including this part of the circuit, well, now that pressure has somewhere to go, because we have a complete loop right here from positive to negative. So the positive potential, because this plate, once it's fully charged, is at 5 volts. That plate will then begin to discharge through here and go through the resistor, illuminate the resistor, and then equalize to the back of the thing, just like when you let go of the plunger on that syringe that you pulled. And then, of course, once the capacitor runs out of pressure, then the LED fades out to nothing. And I'll show that in just a moment here. Actually, I think we're actually at the point where I can demonstrate that directly. So let me just get rid of the whiteboard for a moment. And we'll bring this back in. And I'm also going to need my multimeter here. And actually, I want my alligator clip leads for the multimeter, so give me a second. Oh, maybe I'll use these instead. Yeah, I'll use these instead. These are better. Okay. Alright. Actually, these might be better. But I'll try the other ones. Bear with me a moment as I bang around in the background. Really, I need to get some hooks so I can hang all my various leads on the wall. That's a good idea, Chris. Make a mental note to do that. Okay, so let me just swap out my leads real quick here. I'll get rid of these probes for the moment. And we'll put these little custom-made things I did. I put some banana plugs on one end of some wire, and then I put DuPont pins on the other end. So, but I don't want to use these ones right now because I was going to demonstrate how the resistance of a capacitor changes. Actually, I can still do that with these leads. Okay, so where's my big cap? There it is. Okay, so I'm just going to stick this big cap on an arbitrary position in the board here, and then I'm going to Actually, what I'm going to start by doing is I'm going to make sure that the capacitor is... Go away, LEDs. I'm going to make sure the capacitor is grounded and discharged. Otherwise, that will throw off the results of the test here. And I'm going to put that in the board in an arbitrary position. I'm going to set this to ohms. And then I'm going to take the negative test lead and put it there. And then I'm going to position this so you guys can actually see it. Oh, the polarizer. Oh no. Let me see if I can adjust the polarizer to make that display any better readable. It's going to throw the white balance of the screen off, but it's more important to be able to read the display of the multimeter. There we go. That's good enough, I guess. Anyway, so I'm going to go ahead and apply the positive lead of the multimeter here. Now, this multimeter, this particular one, caps out at 40 megohms. After 40 megohms, it can't read resistance anymore. So let's go ahead and plug that in. And you can see that it's gradually, you can't see this right now, but it was at k ohms, so it was at kilo ohms for a moment there. So I'm just going to ground the capacitor again, and you'll see it's at 0-ish. Now I'll release that, and it climbs right up to overload because I don't know why I did it that fast. So we'll ground out the capacitor again. Oh, because even though I grounded it out, there's still the voltage across it. Anyway, so we'll plug this in. You can see it counts up, it's in the k ohm range, and then it maxes out pretty quickly. I need a bigger capacitor to properly demonstrate. I suppose I could grab the... Wow, I'm being really scatterbrained today. Anyway, so you can see how the resistance of that capacitor went up as it charged, because there is a voltage across this, which I can't demonstrate because I only have one multimeter. Although I suppose I could unplug the lead, set it to volts, and then plug it back in and see what the volt reading is. So the voltage reading is 300 some odd millivolts at the moment. Now if we go back to ohms, yeah, it's fully charged. So apparently this multimeter uses a voltage of about 1/3 of a volt to test ohms. That's interesting. Anyway, so there's a demonstration of the capacitor increasing in resistance as it charges. Now we're going to short this capacitor out real quick. We're also going to short this capacitor out just to make sure. Alright, we'll put that one back across there. We're going to put the positive lead here. We're going to put the negative lead here. We're going to set it to volts. And then you can see a little bit of residual voltage still in those capacitors, but that's alright. What I'm actually going to do here is put... can I sneak this in here somewhere convenient? I'm just going to bear with me a second here. Being very scattered today, but that's alright. So, now I'm going to go ahead and push this button. And when I push the button, you're going to see the LED here is going to gradually start getting brighter. Correct? Okay, yeah. It's just happening a lot slower than I was expecting. And that's because of the this resistor is actually limiting the inflow of current. But you can see it's gradually starting to illuminate here. And it's going to get brighter and brighter and brighter until we see this reach 5 volts. It's probably going to take a fair amount of time with the 22 k ohm resistor in series there, but I suppose I could find a smaller resistor. But the point is there. But then when I release it, we're going to watch that voltage start to droop. So I'm going to go ahead and let go of the button. And you can see the capacitor begins to discharge. And this, now I'm going to go ahead and prove to you that the capacitor is what's causing this buildup of voltage. Please short out capacitor. That's what the purpose of this lead was? Okay. Alright, so now I'm going to unplug the capacitor and then push the button again. Now when I push the button again, you'll see that the LED is going to come on at full brightness immediately, and the voltage here is going to jump right up to 5 volts, and that'll be that. So, bunk. Oh no, sorry, of course it's going to be 3 volts, because it's only measuring the voltage across the LED. If I measure here, it also goes to 3.4 volts. Why are we only getting 3.4 volts? I feel like I'm missing something here. Because if I put it across the whole circuit... Okay, if I put it across the whole circuit, I get the 5 volts. If I put it across this part of the circuit, we're also still getting 5 volts because that's from there. But when I read from here, I'm going to get a little less than 3 volts because there's a volt drop across this resistor that I'm actually not measuring at the moment. That's why it's only going up to 3.4 volts. Hey, I just learned something. Well, I didn't learn something, I just realized I was being stupid about something. So I'm going to quickly, for the purposes of this experiment, adjust the voltage on the other side of the resistor here. That's going to be there. To equal 5 volts after the initial voltage drop. So bear with me just a moment while I tweak this up. I could do the math, but I can also just do it this way by turning my power supply up and watching the voltmeter. Alright, I should have anticipated that when I was running the experiments. Anyway, so let's go ahead and put the capacitor back in, just so I can re-demonstrate this process. And that goes there. Why aren't you working? Because I put you on the wrong spot. It's there and there. Of course, there's a charge remaining on the 8 volts. The heck? That ain't right. What is with the readings I'm getting? It's because I keep putting the probes in the wrong spot. Alright, so let's do this again without the rambliness. And bonk. And we're going to watch that LED slowly grow brighter until we hit 5 volts. Which takes a little bit of time. There we go. Peaking out at 5 volts. The LED is now fully illuminated because now the capacitor is no longer accepting any voltage, so it's fully charged. Now we release the button and the LED slowly fades out. The voltage drops away as the capacitor empties its reservoir through the LED. So yeah, I've had a lot of fun playing with this. You can swap different resistor values into that, but there's a practical demonstration of what a capacitor is used for. It's used as a reservoir for current. Well, for voltage, really. Actually, you know what? Just for fun, I'm going to destroy this LED. Just to have a little bit of fun with you guys. So I'm going to remove this current limiting resistor that I had in series with that LED to protect it from a huge surge of current from the capacitor. Now I'm just going to drop this capacitor directly in parallel with that LED, and I'm going to have to restart my recording soon. Maybe not. Alright, let's kill this LED. So if I push this button, the LED is going to come to full brightness, but when I let go of this button, there's going to be no protection from the surge of current that comes from the capacitor, so this LED may actually fracture when I let go of the button. So let's see what happens. Nope, it just died. Oh, that's actually being... I guess I'd need a bigger capacitor to kill the LED. Anyway, so that's a quick brief on LEDs. If you haven't already, consider clicking here to subscribe. Right over here is a video that YouTube thinks you'll find interesting. Right here is going to be a playlist of some sort. I have absolutely no idea. And right here is a link to Patreon that you can use to support this channel. Thanks so much for joining me, and we'll see you in follow-up videos. Bye-bye.